Now, so after getting this such steepness, this such steepness for other all other equipments, other substation equipments, this such steepness I calculated for the main equipments like a transformer and for the transformer and the breaker. But what about for the other equipments? So generally it is 1000 by 0.5, which is 2000 kilovolts per microsecond. So using the above equations, these equations, E, A, E, B, E, T, E, J, and these such steepnesses, everything. So this is the very complex calculation we have to do. So from this complex calculation, I am calculating all the all the surge voltages across all the buses, by including these constants. One is the number of lines connected, how many conductors per phase, that is one constant I have to use. So from all this, I found this is the surge voltages I can see at all the places. If you see the transformer internal bushing, the surge voltage I am seeing is 660 volts. Similarly, for at all the places, these are the surge voltages I am seeing. Now, after calculating the surge voltages, I am calculating the BAL. I'm starting the BAL calculation. So the BAL calculation should be done for two types of insulators. One is non-self-restoring insulators. One is self-restoring insulators. The non-self-restoring insulators is the insulators when it is damaged, the insulation cannot be retained. Like in transformer internal insulations, internal bushings. So I am calculated the BAL level for the transformer non-self-restoring insulations, and this is the formula I got. And for the self-restoring insulators, I got one formula. So based on this, I calculated these are the surge voltages I got, and I calculated the BAL levels at sea level and at the elevation level. So these are the required calculated BAL levels of my substation. These, if you see, because my substation is 2000 meters elevation, right? So these are the BAL levels I required. So what is the 230 kV? What is the standard BAL levels we have seen in the previous this one? If you see, I'm having 650, 750, 825, 900. These are the standard ratings available. So 690, so I'm selecting 750, 750. You can say like 625, so you can select 650, 750, 750, 650, 750, 750. So this is the level, right? So by taking some margin, because a 15% margin is set, right? So by taking that for this, so I am selecting nearly 900 BAL for my application. 900 BAL. So the 900 is the BAL level of my substation. Similarly, so when I got the BAL level of my BAL level, 900, this is for 220 kV. So to find out the phase 2 ground clearances, I have to divide this 900 by 526, which is a factor, which is a constant, which was derived in this guide in the before pages. If you want, you can see the calculation. But just for a rule of thumb, if you want to calculate the phase 2 ground clearances for 220 kV, just BAL by 526, that's it. So I found 1.71 meters I have to maintain the phase 2 ground. And what is the phase to phase clearances? Is generally 10% of the phase 2 ground clearances. 1.88 meters. So this is the phase 2 ground and the phase 2 phase clearances for the on the lightning surge. Similarly, I am calculating for the switching surges. And I am calculating the calculation for the switching surges. And from this, these are the BSL levels found. And to calculate what is the phase to phase clearances of the BSL, one formula is there. That is the BSL level of the substation. Suppose if you know the BSL level of the substation, then the formula is 8